In this video we'll see how to modify an already created Pspice model in order to be run with the parameter optimizer tool. We'll modify two different models, a static test performing an EGBT and a dynamic one with the turn off response. For the static one, for a given gate voltage, we'll perform a DC sweep in the collector voltage and see the current response. And we are getting the curves from a manufacturer and the same ones as we'll use in the whole video. For the dynamic one, we have the voltage and current response in the collector due to a turn on and turn off that is performed simply by modifying the gate voltage. Okay, we'll open the static model and we'll perform the changes. Okay, we have to perform two modifications only. On one hand, we have to tell somehow the tool what parameters need to be estimated, and on the other hand, we have to write the outputs variables. I'll begin with the second one first. In this particular test, we want to plot the response of the current in the collector versus the voltage in the collector. So what we need to save is the current and the voltage in the collector. We can do so by using the print statement, and we do so by typing print, the type of simulation and the variables separated by spaces. The print command will also add by itself as a first variable the variable that you are sweeping. So for example, in a DC sweep it will add the voltage in the collector, which is what we are sweeping. In a transient it will add the time since it's been let's say swept also. So in this case we just need to add the current, and we'll get as output variables voltage and current, since the voltage is being added automatically. It's better to start putting the output variables, because then we can run the circuit and see if we are saving really what we want to save. We can just do this, press run, and opening the out file we'll see in the middle of it the variables, and we can check if we're saving what we want to save. So we can see here the first variable is the voltage in the collector, and the second the current in the collector as we wanted. We also have to remember the first is the voltage and second is the current, because later on in the tool we'll have to choose these variables by specifying the column order. We can now do the second part, and we can add the parameters we want to estimate. We do so simply by replacing any parameter we want to estimate by the command var param parentheses and the number of the parameter. So we'll begin in var param 1, and we'll go until as many parameters as we want to estimate. You can assign any number to any parameter, it does not matter, but you have to follow always the same order. So for example, in this simulation file I call T2 the first parameter by putting var param 1. So later on, if I have another simulation where I also have T2, T2 has to be the first parameter. That's the only thing you have to follow. So I'll just estimate all these parameters that I want to know, just by putting one after another, var param 1, var param 2, and so on. Okay, we can save now, and the model is already ready to be used in the parameter optimizer. Those two are the only two changes, small changes you have to do in your model. Hope everything is clear, and if you have any problem, just go to the website and write there. I'll show you now in the second model, in the dynamic one, how to perform the changes. And the changes you have to perform in second model are the same ones as in the first one, but I've chosen to choose two different models just to show a more general solution, also because this one has the time in it. So anyway, we begin opening the simulation file, and we have to perform the same two changes again. As we remember, we have two curves now, not only one. One is the voltage over time, and the other one is the current over time in the collector. So we begin by putting the output variables we want to save. So in this case, we write again print followed by type of simulation, which in this case is a transient simulation, and then the variables to save, which will be the voltage and the current in the collector. This particular model, voltage in the collector is V8 minus V9, so we just put V8, 9, and for the current we have IXVD1 2.1. It depends on the model. In this case it's like this. So when we write this command, we would expect to have as a first variable saved in the out file the time, the second would be the voltage, and the third the current. Let's simulate and see if we're right. We can just do so by simulating and again opening the out file with the same name as the zero file. And if we scroll down, we'll see in the middle the variables have been saved, and as expected, the first one is the time, adds automatically by the print command. Second one is voltage, third one is current. So everything is fine. We have to remember the order again because it will be important later on in the parameter optimizer tool. Okay, so this part is already done. I will do the second one where we set the parameters to estimate. We just copied and pasted from the previous one because it's the same. We have to follow the same order, it's important. But in this particular one, we also want to estimate the parameters in the gate circuit because they are difficult to measure in the lab. So small modifications may make the optimization process very complicated, so we also need to estimate those. If you notice, we are just putting a following by the previous number the next parameters. The order does not matter. It doesn't matter that the first parameter that appears in the file is not the first one, but the order is maintained. And we can also see that in this file we have more parameters than in the previous one, and again this is not a problem, it's perfectly supported by the tool. So we just save this and the file is ready to be used in the tool. Hope again everything is clear. Any doubt, just go to the website. Thank you for your time.